So in this video, we're going to talk about x-intercepts. And conceptually, x-intercepts are a perfect parallel to y-intercepts. In practice, they can be a lot harder to find. If you compare my stated goals for the third and fourth set of notes, the goal for the third set of notes is to find y-intercepts, be able to find and interpret them. My goal for this set of notes is to find x-intercepts, be able to find or at least interpret them. So I seem to be saying right off the bat that we might not always be able to find these things. Let's consider why that is. So x-intercepts, in terms of their definition, perfectly parallel with a y-intercept. You've got this axis, you've got a curve that sometimes intersects the axis. Maybe it happens more than once. You can have multiple x-intercepts. And the x-intercepts are the points where it happens, where the y-coordinate is 0. To see the issues involved with finding x-intercepts, let's go right back to the example we did for the y-intercept. We've got this situation where an object is being thrown off a platform, and as time passes, the object's height changes. According to the following formula. When we wanted the y-intercept, we set x equal to 0, and it was straightforward to find y. We let x be 0 and just read y off to find the x-intercepts. We set y equal to 0. And suddenly things have taken an ugly turn. Instead of being able to read x off, you have an equation that you need to solve. And maybe it's easy to solve, maybe it's hard to solve, maybe it's completely impossible to solve without computer assistance. Many of you may know how to solve this from high school algebra, but we certainly haven't learned it in this class yet. If you haven't seen the quadratic formula, you are out of luck and will not be able to continue. Can we interpret the y-intercepts, even if we can't solve them? If we graph this thing, it looks like this, and there are two y-intercepts. However, only one of them has any meaning. Remember when we were discussing quadrants, and I said that in a lot of real-world situations, we'd be stuck in the first quadrant. That's exactly the case here. The height and the time both have to be positive. So the second quadrant, where time is negative, that's out. Third quadrant, where height and time are both negative, that's out. Fourth quadrant, where height is negative, that's out. The only part of the graph that has any meaning is that part. And we have a single meaningful x-intercept. What does the x-intercept mean? Can we interpret it even if we can't find it? Well, to find this intercept, we set y equal to 0, and y is the height. So this is the time when the height of the thrown object above the ground is 0. What is that moment? Well, what's the time when the object hits the ground? So just like with y-intercepts, x-intercepts usually have some kind of concrete meaning.